Hi, welcome to Cosmos Redshift. In our previous two lectures, we have discussed about the scalar product and the vector product. In this particular lecture, we will discuss some more type of vector products, not more type of vector products, mainly scalar and that vector products, but their combination. So we'll see some the vector multiplication in some more complex scenario, and also we will see some reality of the cross product. The first thing is that suppose you are standing on the equilateral of the earth and the earth is rotating. Now, in which direction the velocity of any instance directing, how you can find it? So you can find it, suppose that is the along the axis omega. So right, you know right hand rule, thumbs rules, and that is the radius. Okay, now radius and this are perpendicular. Now how we can find that velocity is this direction? Because this omega and this radius, if we find the cross product of these two, then it will gives the result what is also perpendicular to the both of them. So it is the region of the velocity will be that direction. Okay, now another thing is that vectors, this is a concept of the scalar triple product. In our previous lecture we have seen that the area of the area of a parallelogram is represent the magnitude of a cross product. Okay, the magnitude only, not the direction is the perpendicular to that surface area, but it is the only magnitude of the that. So you here from the B cross C you can have the area of the parallelogram. Now here the scalar product, scalar triple product is saying that scalar triple product can give you the entirely volume of that and paralleloid. More of the thing is it is the 3D picture of the previous one. So how we can do this 3D picture? So we have already B cross C, that is the area of the base, and now to find the volume you have to multiply the base into height. But here is that A is not that height. Okay, because A is not that vertical area, A is just another vector here. What is going to multiply with them? What is the height should be this. Now what is the direction of this B cross C? This direction will be perpendicular to this surface. We can say this angle as a theta, right? So this angle, from the basic elementary geometry you can see that this angle also be the theta. So we have that theta. So height, we can find that this height h here, that is a cos theta. So the volume, how we can multiply? The volume should be the area into height. So B cross C, A B cross C, that cos theta. So that will gives you A dot B cross C. Okay. Now you have seen that the scalar triple product. Now here is a calculation of the scalar triple product. How we can calculate? First thing is, you can calculate that B cross C. From the previous lecture we have seen how to calculate cross product. B cross C is by cz minus cy bz ex plus ba bz c. These long terms actually what you have seen in the previous lecture, and you have to do a dot product with this. Okay, now how you can do that? Ex with the ax by cz minus cy bz plus ay this and this. Now you can write these things with the determinant as well. How? Instead of that, in the cross product we have seen by the determinant using the unit vector at the top along ex. Here will not give the ex that space. Here will give you, sorry, ay and az, bx by bz and cx, cy, cz. This is our the mathematical form of the scalar triple product. Now if you see that scalar triple product is gives you the volume of this rectangular boxes. Okay, now if you call that c as a b and b as a c, a as a b, if you change its position, it does not change its real volume, and the scalar product always give you only magnitude. There is no question of direction here. So you can change the position of a, b and c, every three element from one place to another, but the entire volume that you are getting it the same. So you can write that a dot b cross c is equal to b dot a cross, c cross a and c dot a cross b. Okay, now another important idea here is here, if you fire a proton into a magnetic field, you can see that the proton will be the trajectory of that proton will be bent like this. Now now from your elementary knowledge of physics, you can see the Lorentz force. You can define the Lorentz force as Q is equal to V cross B, and from that you can define the from your classical mechanics, you can define the power or the work rate, that is V dot F. Now the force is now you can substitute that F into here, the F into there. What will get? Q dot V cross B cross V. Now look at this. Here it is a scalar triple product. Okay, scalar triple product. It is a scalar triple product, and interestingly scalar triple products is give you some volume of a boxes. But if two vectors is the same in a triple product, what will it give you? It will give you 0, because if a, b and c, if you think that two vector in the same direction and the same component and everything is same, then the box will never completed, so the entire volume will be 0. So the power will be also 0 for this. Now another interesting concept of physics is the angular momentum. How you can define an angular momentum? You can define an angular momentum is equal to cross product of radius with the momentum. The momentum is equal to mv and the velocity is the tangential velocity. The tangential velocity can be defined as the angular velocity cross of with the cross of the radial vector. Okay, now finally if you substitute that in that angular momentum, so you will see m into r cross. Now this p, the meanings of this p is equal to, you have that m already common, so here is omega cross r. So it is another product, but it is not a scalar triple product, it is a vector triple product. Okay, vector triple product, not scalar triple product. So if we once we know the vector how to solve vector triple product, you can find some more precise formula, you can find the formula that you already know, and there is the triple product. Okay, yes, a vector, here is the vector triple product. What is there? The first thing is, we already know to the b cross c, this is the b cross c, that is along the x component, it is along with the y component, it is along with the z component, and we already know how to find the cross product ex, ax, y, ayz. Now let's see how to let's find this product and to finally. Okay, now this is the thing you are seeing here on the board, that is that ex component, it is along ey component and it is along the ez component. Okay, now what I can have, let's rewrite it is and rewrite the things and simplify it. Okay, how we can write it? Ay bx cy how we can write it? you can write it in these terms entirely for the only for the EX component. It is we are talking about not entire mechanism. We are only with handling a single component, that is EX component. So how it is? Let's AY BX CY minus AY CX BY minus AZ BZ CX plus AZ CZ and BX. Okay, now one thing we can do with this also is we can add AX BX CX and subtract this AX BX CX and subtract this. Now we can simplify this. Okay, how we can simplify this? We can simplify this by taking the BX as a common, and we'll get you AX CX plus AY CY plus AZ CZ minus of, you can take the CX common now, and if you're taking the CX common, then you will get AX BX plus AY BY plus AZ BZ. Okay, now you can see, if you look at closely these terms, that only we are talking about EX component here only. The rest of the things we are not discussing here. Okay, now the EX component will be BX. Now you can see that this is that A dot C. Okay, minus of CX, it is A dot B. Same way you can find that component of EY and EZ. What only to do? In that component of EY, you have to add AY BY CY and subtract it, and in the component of EZ, you have to add AZ BZ CZ and subtract the same, right? So here it is. So here in the previous slide we have seen the BX component, X component is like this. It is look like B A dot C minus CX of A dot B. Okay, it is along with the only EX axis. Now what with the EY axis? Kind of quite similar type of things will happen there also. BY, you will see that you can do it yourself, the entire things. I am doing only one component and getting the final result from there. CY A cross B, and it is EY. Okay, and another component will be there is plus Z. Z component will be BZ A dot C minus CZ A dot B. Okay, EZ. Okay, now we can take it. Now we can more simplify again. We can simplify it some more, that BX EX A dot C plus BY EY A dot C plus BZ A dot C, that is EZ. Okay, this is the for only we have doing in the B, and now minus of again CX EX A dot B plus cy uy a dot b plus cz ez a dot b. Okay, now you can see that if you take common a dot c from first and second, then what you will get, that bx ex plus by ui plus bz ez, that is your basically vector b. So the finally the result you are getting is vector b into a dot c minus of vector c into a dot b. This is called this rule is called BAC minus CAB rule for the triple product. Now as you know that how to find the triple product is BAC minus CAB. You can find it by yourself, and here now important aspect is that we have find that this is a triple product of that R cross of omega cross of R. Here we are considering this is B. So omega BAC omega AC, that is R dot R minus now CAB. So R omega dot R. Now one thing you can see that you are that omega and R are the orthogonal, okay, are orthogonal to each other, and if it is orthogonal to each other, then the orthogonal dot product of an orthogonal two orthogonal vectors will be gives you the 0. In our previous lecture we have seen, so this part will be the 0, so only the remainder part will be omega R square. So what will be the angular momentum? M omega R square. Now if we take that m R square omega, and this m R square is our I, we are called it moment of inertia, okay, moment of inertia, that is moment of inertia, and this is our angular velocity. So we get from the cross product we get our angular momentum as well. Now we have solved the cross product, vector triple product as well, but here is come to the main player of the game scenario, that is the Levi-Civita. Levi-Civita, the more you have to include the dimension to do a product, finding a vector product, Levi-Civita will be that much helpful. The more it is game of the 3-dimensional to 4-dimensional game is going, Levi-Civita will definitely become the Lionel Messi of that complex games. Okay, how now we have discussed the Levi-Civita already in our previous lecture, but one thing we have left, the relation of the Levi-Civita symbol and the Kronecker delta symbol. Okay, we know that Kronecker, when the Kronecker delta gives you output and when not, we know that. We know also that when the Levi-Civita gives you output and when it is giving you the positive output and when it is giving you the negative output as well. But in this segment we'll understand the how the triple product will be helpful by doing this. Okay, now how? The first thing is this is epsilon ijk and epsilon kmn. First thing you have to find that what is the common shared index between them. Here it is the k is the common share index between them, so k is will not think about k. We are finding the actually what is the common index. We are finding the product in that actually component. Okay, we are finding this product into the k component actually. Now what will be the relation of this will be delta first into first, the delta first into first and second into second, second into second, minus of first into second into second into first. Okay, the I m delta I m j n minus I n and j m, first second that is a very simple rule. Now let's see an product. Now find this product through the Levi-Civita symbol. We have did a lot of hard work to find that vector product, but here is some elegant lavish method that will help you to find a triple, even the triple product within instance. How? If we see that we are not, in our previous lecture we have said that we are not going to find the entire product through the Levi-Civita. We'll find some component only. Here is isolating the component of the first component, ith component. Okay, we are finding the a cross b cross c is what is going the ith component. How we can find that? We can find this j1 j is equal to 1 to 3 and k is equal to 1 to 3 ijk aj b cross ck, and that can be written in that from that epsilon b cross c can be written, that is for the k of course, that m and n. So we can say epsilon ijk, epsilon kkm, kmn, aj, bm and cn. Okay, that is our, by definition it is our thing. So what is our epsilon ijk, epsilon kmn? What will this? That will be is our delta of im delta of jn minus delta of in and delta of jm. Okay, delta fine and delta of jm. Now look at this. If you, now you can put this into there. Okay, now one thing you have to remember from the previous lecture actually, that Kronecker delta will gives you always delta ij will be 1 when I is equal to j, and it will be 0 when I not equal to j. So the first instance we have to equate that I equal to m and j is equal to n. Right, so I is equal to m and j is equal to n for the first instance, this for this, and for okay, for this you can see that I is equal to n and j is equal to m here, because only that in that way it will give you one positive one output, otherwise it will be vanish out the terms, the terms will be vanishes out. Well, now what is this sum of? We can say I is equal to m, so epsilon delta, that will the both will be, the value will be 1 because I m and j n, but in that case we are taking about epsilon a is already j here. Now bm, b is equal to bi and cn is equal to cj. Okay, we are working on component of j 1 2 3 minus of here is same, j is equal to 1 2 3. Now here is equal to I is equal to n, so aj is equal to aj will be same here. Now here bm, m is equal to here j and c is equal to here what I. Okay, Now that is, so that can be written as bi. You can take this bi and j is equal to 1 to 3 aj cj minus you can take this ci out of their summation, j is equal to 1 to 3 and aj bj. Well, now we have seen this all. Now it is the sum of from 1 to 3 aj cj, it is the dot product, okay, a dot c. So it gives you that bi a dot c here minus ci a dot b here, for the first component. In the second in the same way with the Levi-Civita, you can find the second component, that ij. So that is bj will give you what, a dot c minus cj a dot b. Same way that is along with the ey component, okay, and the same way you can find the ez component, that with that bz a dot c minus cz a dot b, okay, that is the ez component. Okay, now if we do now you have find enough space where we have find that thing. So if we find the entire triple product with the all the component, what will be there, as we see, BAC minus CAB, B A dot C minus C A dot B. Thank you so much for
वीडियोस बनाने हैं, फिल्मोरा है ना।